This is Geometry, Chapter 9, Lesson 4 on page 358. Still on the topic of area. And this lesson deals with the area of parallelograms and trapezoids. All right, so remind me, what do we know about a parallelogram? What is every fact that you know about a parallelogram? Yes? Opposite sides are parallel. Yes?
I was going to say parallel and equal.
And equal. Opposite sides are equal. What else do we know about parallelograms? Sarah?
The height is the perpendicular distance from the base to the opposite side.
Right. That is new in this lesson of what the height of a parallelogram is. But in previous lessons, what else do we know? Opposite sides are equal and parallel. Yes?
Adjacent angles are equal.
Adjacent angles are
They're
supplementary. That's right. Adjacent angles are supplementary, but opposite angles are equal, right? Parallelogram has two sets of parallel sides and two sets of sides that are equal. In a parallelogram, if this is your base, then the height is not the length of that side. It is not length times width like a rectangle. It is base times height. And the height is perpendicular to both of the opposite sides, So the altitude can lie inside the parallelogram, or it can go from this vertex perpendicular to the base. Either one of these is considered your altitude or your height. So the area of a parallelogram is just base times height, and your height is that line that is perpendicular to both of those sides. Okay? Got it? The area of a parallelogram is the product of any base and its corresponding altitude. This is its corresponding altitude. All right, a trapezoid is different. With a trapezoid, remember we have two bases and two legs. You remember that? Two bases and two legs. And actually, if I just take this little triangle off, flip it and rotate it rather, and put it here, you almost have a rectangle. But instead of adding areas, because really you could add those two areas, here we have a base and a base. And the same is true, we'll call it base 1, base 2, because the bases are not the same in length, right? And our altitude is the same as that, as in a parallelogram. It has to be perpendicular to both of those bases. For the area of a trapezoid, we average the length of the bases and multiply it by the height. So it's really 1/2 the sum of those bases times the height. Got it? You're literally averaging those bases. And so theorem 41 says the area of a trapezoid is half the product of its altitude and the sum of its bases. I say it different from the book. You're really averaging the bases. I say it's 1/2 the sum of the bases times the altitude. I think this is more correct. Can there be more correct? A more accurate way of stating it. All right, now that is this lesson. Let's work some of the homework. We will start Let's just start at 1 through 24. All right, we'll walk through some of this. All right, do you see the photograph on page 360? It shows an automobile loading area in Belgium. Sarah, we'll start with you. What fact about the areas of two parallelograms with equal bases and equal altitudes do the two figures suggest? What fact about the two areas of the two parallelograms with equal bases and equal altitudes do these two figures suggest? They have equal areas, right? They would have equal areas. If they have equal bases, equal heights, they have equal areas. The first one looks like a rectangle. The second one looks like a parallelogram, but its height is still 5 car lengths. Michael, if each car occupies a space 14 feet long and 8 feet wide, what is the approximate area of each figure? The top figure and the bottom figure. So what would be the length of X?
The length of X would be, 14 feet long, so it would be 14 times 5, which is 70.
70.
No, so it would be 70 times 8 times 5, which is 40, so 70 times 40, 7 times 4 is 28, so 280.
And another 0, right.
No,
2,800, that's right. So it'd be 70 is the length of X, 40 would be the length of Y. 70 times 40 is 2,800 square feet, or feet squared. What, Hannah, is the perimeter of the first figure?
Is it 220?
Yes, 220. It's 70 plus 40 plus 70 plus 40. Okay, what would be the perimeter of the second one, and how would the perimeters of the two compare, the top and the bottom? All right, in the second figure, you now have you now need to calculate the length of a side. You know this is 70, you know that is 70, but you have this imaginary right triangle that you have to take out. And what is the length of the right triangle? What's this leg? 14 by what's this leg? It's 40. So what is this side? How do we figure out this side? Pythagorean theorem. Do you remember the Pythagorean theorem? That's in the latter part of this lesson. I mean, it's in the lesson on Monday. What does Pythagorean's theorem say?
A squared plus b squared equals c squared.
Okay, so 14 squared plus 40 squared is going to be that side squared. What's 14 squared?
196.
What's 40 squared?
1600.
What's that added? 1796. Take the square root. What's the square root of 1796? In your calculator.
42.3792.
Okay, we'll say 42.4. All right, so the length of this is about 42.4. All right, so it's 70, 70, 42.4, and 42.4. Would we have known that this perimeter had to be bigger, larger than the other one? Yes. Why? Because when we slant it, this is always the hypotenuse. The hypotenuse is the longest side. It's absolutely going to be longer than 40. So this perimeter had to be larger. All right, look at number 5. If two parallelograms have the same area, does it follow that they have the same perimeter? No, it doesn't. Because is that top figure under 1, is that a parallelogram? Yes. The second figure is a parallelogram. Just because they have the same area does not mean they will have the same perimeter.